All right, we're back. We're on page 2 of notes 27. We're going to do repeated linear factors for partial fraction decompositions, and we're going to integrate the thing, which is actually our ultimate goal, is like to do the integral. So what could be happening here? So say we had something like 1/2 plus 3/8 plus 1/16. You add all those together, you get 15/16. But the issue is, like, once we've done that, like, what fractions did we add together to get that? Because 2, 8, and 16 are all powers of 2. So, like, it could have just started out as 15/16. It could have been something over 8 plus something over 16, something over 4 plus something over 8 plus something over 16. Like, there's no way to really know. So what we want to do when we have this scenario, so we have a factor that is not to the first power, we have to account for every power of that factor, right? So for here, we could potentially have had something that looked like a over 2, b over 4, c over 8, and then d over 16. You could have had all of those, and you could add those up and potentially get some number. I'm just going to say like k over 16, right? There's no way to know, so we have to account for every value, every power from the first power up to the highest power that we see. So that's what we're going to do. Same rules apply, though. If it's a linear factor, we have to have a proper fraction. So what can go over a linear factor is a constant. So let's see if we can decompose this and understand what we're saying. So we see x plus 3 to the second. So we could have started with something over x plus 3, and then something else over x plus 3 squared. So that's what we're going to basically do. We're going to say a over x plus 3 plus b. 3s are like my worst number to write, so I'm glad I chose so many of those. Squared is equal to 2x plus 7 over the quantity x plus 3 squared. All right, so the question becomes, like, can we use the cover-up method on this? You can use the cover-up method, but it will only find the highest power thing. So b is above the highest power thing, so we can use the cover-up method to find b in this case. So I'm actually going to do that. So I look at this, and I like to do that in one swipe so it doesn't look funny. I look at this, I say, what makes that equal 0? So if I let x equal -3, I'll know that b is equal to, I go over here, I cover this up, which is kind of a weird thing to do. Then I'm going to plug in -3. For every x that remains, I get -6 plus 7 is 1. So I actually know that b is 1, which is helpful, right? Because we have to solve for a and for b. Cover-up method is not going to work, however, to solve for a, but we do know that b is equal to 1. So if I choose another value for x, I should have only one thing I don't know. It would be a. So let's do that. Let's say, what would be a good choice? I think that -2 is a really good choice. So I think if x is -2, it's a really good choice because -2 plus 3 is 1, and like all those x plus 3's just become 1. Your life gets a lot simpler. So we'll end up with a over 1, and then plus b over 1, but b we know is 1, and then -4 plus 7 is 3 over 1. So here I know that a is 2. All right, so like you can make these clever substitutions. They don't even need to be clever, actually. You just need to get 2 equations and 2 unknowns. And once you have that, you can like solve. So that's another possibility, is you just kind of like go for it. So we want to integrate 2. So I'm going to pull the 2 out. 2 and then 1 over x plus 3 dx, and then plus 1, which I'm not going to bother writing. I'm going to make this x plus 3 to the -2nd, and then a dx. So this becomes 2 natural log absolute value of x plus 3, and then minus 1 over, I'm reversing the power rule, plus c equals. So I think that's going to be our answer. Are there other ways to do this? There are other ways. Let's first check and just see, right? Because what if it didn't go right and then we had to do it all over again? Integral of 2x plus 7, I forgot the x, 2x plus 7 over quantity x plus 3 squared with respect to x. So 2 natural log absolute value of x plus 3, and then minus 1 over x plus 3, and the calculator doesn't put plus c. So we got it. So what else could we have done? We could have gone kind of the long way around. So some people don't really like this, like use cover up for something, use something else for something else. I like it. What if we went back to our original thing? Not our original, but our first step here. We could have just cleared out denominators, right? Multiply everything you see by x plus 3. So that would give us the quantity. So I need this bigger. So down here, I'll do this in a different color because this is like, we don't need to do this because we already got the answer and we're done. But like, you know, what if we would get x plus 3 times a plus b equals 2x plus 7. So you can see here, if you just pick two different values of x, they don't even need to be clever. You'll get 2 equations and 2 unknowns and you can solve it. That's like a really good strategy. What if you kind of like look at this and you think to yourself, like, what if I took the derivative of both sides? So why would you say that? I don't know, because it might work. That's the main reason. So I'm going to take the derivative of this. I'm going to take the derivative of this. So on this side, the derivative of this, I have ax, 3a is a constant, b is a constant, so I just get a. And on this side, the derivative of 2x is 2. And look at that. By taking the derivative of both sides, I got that a equals 2, like right away. Once I know what a is, I can go back and solve for b using substitution or using equating coefficients or like whatever. We also could have straight up equated coefficients and done that. Either way, it doesn't make a difference. All right, let's try another one. So what do we got here? We got, we're going to do a over x minus 3 plus b over x minus 3 squared plus c over x plus 4. So what can I use the cover-up method on? I'm going to be able to definitely find c by using the cover-up method, right? Because that's a non-repeating linear factor. Cover-up method will always work on those. We can also find b because that's the highest power of a linear factor. I'm saying that wrong. Its denominator is the highest power of a linear factor. I mean, I feel like everyone's kind of like getting what I'm saying, but you know, you want to be right when you say things. 5 over x minus 3 squared, x plus 4. Okay, so step 1, let's solve for b, I guess. So I see this. I'm going to let x equal 3, and this will be solving for b. And then I go over here and I cover it up, and then every x that I see is now 3. So 2 times 9 is 18, minus 9 is 9, plus 5 is 14, over 7, so 2. That's pretty nice. That wasn't bad. I thought it would be worse. We get this, and then we can also use a cover-up method to solve for c. So we look at this. Let's let x equal -4, and we'll know what c is. So we go over here and we cover up this. And then if every x that we see is -4, 2 times 16 is 32, minus 12 is 20, plus 5 is 25, over every x that we see is -4. -4, oh, gross. -4 minus 3 is -7, squared is 49. Okay, that's not great. Is that even right? I mean, like, I'm so skeptical because it's just like not a nice value. Let me just check it, right? 2 times 16 is 32. Then I'm going to add 12 and get 34. And then, well, hold on. Like, I'm getting something different and it's even worse. 2 times 6, what am I doing? Okay, x equals -4. Here we go. 2 times 16. Should I just like do the work? I don't like doing the work. Here we go. I'm gonna cross all this out. Doing the work. All right, so 2 times 16 is 32. plus 12 plus 5 over negative 7 and then squared over 49. So we get 30, 44, 49, 49 over 49. Look at that. I was skeptical because it was an ugly number, which isn't really something you should be skeptical of. But it turns out that I saved myself from making a horrible error. If you get gross numbers, check them twice before you dive in. So I think this is but now I'm probably doing the opposite where I'm like, oh, I got 1, so it's got to be right. All right, now I need to just pick something else that'll allow me to solve for this. So I could pick, I have like several choices. I have an infinite number of choices actually, as long as I don't pick 3 or negative 4. I'm gonna choose, I don't know, 2? It's either 2 or 4, I feel like are like the best choices. I'm gonna choose 2, maybe I'll regret it, who knows. X equals 2. So if x equals 2, I get a over negative 1, so negative a. And then, so the advantage of 2 is that 2 minus 3 is negative 1, but the squared is positive 1, so I just get b here, so plus b. Oh, but then we know what b is. So b is actually 2, plus 2. And then c we found was 1, so it's going to be plus 1/6. So that's kind of gross, but whatever. Plus 1/6 equals, so every x that you see is going to be 2. So I might have wanted to rethink this strategy, but no, not going to do it. I'll be able to just multiply through by 6 and like clean this up right away, I think. All right, 2. So 4, 8 minus 6 is 2, plus 5 is 7 over negative 1 squared, and then 6 over 6. Let's multiply through by 6. Negative 6a plus 12 plus 1 is plus 13 equals 7. So if I subtract, I get negative 6 divided by negative 6. I get a is 1. I'm pretty confident because those are some nice looking numbers. Now, is there a better way to do this? I don't know. Are there other ways to do this? For sure. So like what we could have done is we could have multiplied through, and then we could differentiate. And differentiating will reduce the powers, and so your constants start disappearing. So like that's a possibility. I instead am just going to integrate. So I'm doing a is 1, so I have the integral of 1 over x minus 3. B is 2, so I'm going to say plus 2. The integral, I'm going to bring this up to the negative second. And then c was 1, so I'm going to say plus the integral of 1 over x plus 4 dx. So natural log absolute value of x minus 3. All right, plus 1 times the reciprocal gives me negative 2 over x minus 3. And then plus the natural log of the absolute value of x plus 4. And then plus c. Should we check it? Probably. I probably should have checked the expansion before I like did the problem, but can't win them all, you know. Integral of 2x squared minus 3x plus 5 over quantity x minus 3 squared. So that was our repeated linear factor. And then x plus 4 is a non-repeated linear factor because it's the first power. X. All right, so can I expand this? Expand. Oh, I love that trick. So natural log absolute value of x plus 4, natural log of absolute value of x minus 3, minus 2 over x minus 3, plus c because we're humans. So we got it. So I think that's pretty good. So this, it's like a mixture of using the cover-up method for anything that you can. Always use the cover-up method if it works. Use the cover-up method for anything that you can. You should be screenshotting right now. And then when you are done using cover-up method, just make like judicious choices for the remaining variables, right? So I try to make things equal 1 if I can. So like I would choose like, in this one, the denominator is x plus 3. So I would choose x equals negative 2 because negative 2 plus 3 is 1. Other good choice, 0 is always a good choice if you can choose it because, you know, 0 times anything is 0, 0 to whatever is 0, like zeros are great. So hopefully you screenshot everything you need, and I am going to end the video here, and I will come back in the next one to do more of this stuff. So I will see you then.